In this video, we're going to talk about unit vectors. In order to understand what a unit vector is, it might be helpful to think about the concept of unit price. Here are some examples. I bet you've been to the store before and you've wanted to purchase something and there were two different choices and you weren't sure which was the better deal. Well, unit pricing makes it easy for you to determine which is the better price. In the images, we see a product 1 and a product 2, and it looks like we're dealing with a cereal, multi-meal frosted cereal. You see in this example, the first one for product 1, that there is a price of $2.99, and that is for 18 ounces. Now, circled, it says per ounce. This is the price per ounce. That price per ounce is 0.166. Where does that come from? Well, notice how this is listed. It says price per ounce. So that 0.166 comes from taking the price, $2.99, and dividing it by the number of ounces, so 18 ounces. And if you put that into your calculator, 2.99, I'll go ahead and write it out, 2.99 divided by 18, the number that you get is 0.166. Now, that is a price per 1 ounce. That is a price per 1 ounce. And how do I know that? Because up in the numerator was the dollar symbol. So up in the numerator is still the dollar symbol. And then down in the denominator were the number of ounces. So by doing that division, I'm finding out how much each ounce costs. I could do the same thing with product 2. In this situation, the price is $5.59, and I'm going to divide that by 36 ounces. And if you put that into your calculator, you would get a price of 0.155, so almost 16 cents per ounce. And we can see the same thing in the third example. This one looks like it's another cereal, Flavorite Crispy Rice. And this one is $2.99, but this one is for 12 ounces. Remember, we saw this price of $2.99 on product 1, didn't we? We saw that. But that one was for 18 ounces. This one's only for 12 ounces. So I'm going to expect the unit price to be a little bit higher. And sure enough, it looks like this one has a unit price of just about 25 cents, isn't it? So 20.249 per ounce. Okay, so why are we talking about this? Well, unit vectors are like unit price in that they involve the number 1. Now, what 1 am I talking about? I'm talking about that 1 ounce, 1 ounce, 1 ounce. They all had different number values on the numerator, but they all dealt with 1 ounce. That's what made it a unit price, a 1 unit price. Unit vectors are the same thing. Unit vectors are like unit price in that they do involve that 1, where the component of a position vector can be expressed using what we call unit vectors. And like you might imagine, a unit vector has a magnitude of, what do you think it is? How about 1? It has a magnitude or a length of 1, where the horizontal unit vector is written as I is the traditional horizontal unit vector, where that unit vector is equal to a component of 1, 0. So that is starting at the origin, and going 1 to the right and going nowhere up and down. And it's directed, like we see, along the positive horizontal axis. The vertical unit vector we call unit vector j, and that is the same thing that we just saw with unit vector I, only now we're starting at the origin and we're going nowhere along the horizontal axis and we're going up 1 unit. That is what makes it directed along the positive vertical axis. Now, just like with a unit price where we did a lot of division, the price of the item by its size, a unit vector can be found also by dividing. If the vector v is a non-zero vector, then if we take that vector and we divide it by its magnitude, that will be a unit vector in the direction of the original vector v. And we're going to look at some examples of those in just a minute. So let's take a look at an example. Part A says to express the position vector v equals 3, 4 using unit vectors. All right, so unit vectors are that concept of i's and j's. So I'm going to call this position vector simply 3 unit vector i's plus 4 unit vector j's. That simply indicates that along the horizontal axis, starting at the origin, because it is a position vector, that I'd be moving 3 units to the right, and then I'd be moving 4 vertical units up, and that's what would get me that position vector. Part B says to find a unit vector in the same direction as vector v. Now, if you take a look at vector v in this image, I could find out that magnitude, couldn't I? In fact, let's do that. What is the magnitude of vector v? The magnitude of vector v is equal to the square root. We've seen this before. We're going to use the Pythagorean theorem. We're going to take 3 squared plus 4 squared, and then we're going to square root that. So 3 squared plus 4 squared, that's 9 plus 16, which is 25, and the square root of 25 is 5. So vector v is definitely not a unit vector, because if it were, then this number would be 1, and it's not, it's 5. So what we want to do is we want to come up with some unit vectors that are in the same direction as this vector v. And the way that we do that is by doing this division, okay? Now, sometimes you will see unit vectors written as a u with a vector over it, and that implies that we have a unit vector. So let's go ahead and use that. I'm going to take vector v, which is 3 unit vectors in the horizontal direction, plus 4 unit vectors in the vertical direction, and I'm going to divide that by the magnitude of vector v, which we just came up with as 5. All right. Now, I could leave it like that, or I could actually do that division and call this 3/5 I plus 4/5 j. And I suppose I could even use a calculator if I preferred, and I could say that this is 0.6 I plus 0.8 j. Now, here's what that means. That means that if I start at the origin and I go to the right 0.6, so not even 1 whole unit, and then I go up 0.8, so again, not even 1 unit, that the length of this vector that is created by that horizontal and vertical movement will have a length of 1. Now, I can verify that this is a unit vector by finding its magnitude, right? What is the magnitude of the unit vector? Well, just like you saw me do with the original vector, I can do the same thing here. I'm going to take the square root of, what do I have? 0.6, but I think I'm going to call it 3/5. I like working with the fractions a little bit better. You can use the decimals if you prefer. Plus 4/5 squared. And what is that equal to? That would be equal to 9 over 25 plus 16 over 25, which is 25 over 25. 25 over 25 is 1, and the square root of 1 is 1. So the fact that I just found a vector with a length of 1 verifies that I really have found a unit vector. So, how many of these unit vectors could fit on the original vector v? Well, remember that the original vector v had a magnitude of 5. So I would expect that there are 1, 2, 3, 4, and 5 unit vectors that could fit on this original vector, and sure enough, they do.